Okay, so moving on to the next presentation. We thought it would be useful to talk with you a little about some of the client-server interactions. The point of this is try and tell you some things that are different than what you might expect from client-server, where if you think of client-server as sort of a PC and a internet service provider, and explain what's different about that with these. And I won't go over a whole set of things that are different, but focus on a few of them that we provide a much better experience for users based on these things. So the things I was going to talk about in this presentation was the unified login model, the two-way authentication we do, and some of the non-traditional clients are split. And again, there are a lot of other things in this area. I think these are some of the key points when you're talking with people about what Microsoft TV client and server provide that give you some of the expanded functionality that we have available. So the first part on the unified login model, and that is that when someone turns on their client, it will connect to a single site, which we call the head waiter, and that's where a client logs in. They're presented with a user, they present their username and their password, although a lot of the login is based on physical possession of the box. So if you only have one user on a box and that user has no password, it will just connect right through without doing this. Now, when the box first connects, and this is something that we're working on with combined with a cable UI, you may want to have some stuff that's available to sort of a household account, something where you don't have to log in as a specific user. So again, headwaiter could provide a general purpose, non-password account, which is a household account. And then beyond that, if you wanted to do additional things like mail that required a specific user associated with them, you'd go through the login. But it's a very flexible thing where depending on how many users are on the box and whether the users have passwords, there may be no user interface involved, or there may be a lot if they have to select from different people. But in any case, under the covers, what's happening is the client is going to headwaiter. When it goes to headwaiter, it will receive back from headwaiter a ticket and then a list of services that will honor that ticket. And this list of services actually has multiple machines for each service, and this is one of the ways that we get our availability and also scalability, is that we determine at the time that box connects which services it's going to use, and also give it some redundant services, so if one of them is down, it can use an alternative. And I'll go into a little more detail on that. This ticket is encrypted blobs. The client can't actually read or modify or change the ticket, but the ticket includes who the user is, what capabilities are, what the encrypted session keys are that are going to be used. I'll talk about that in a little more detail. The important thing is when a client connects to one of our services, it presents the ticket, and that ticket both identifies the users and gives the capabilities of that user. And this is what I was talking about when I was doing the walled garden stuff with the proxy. That's how the proxy determines who is currently logged on to this box and what capabilities they should have. This is different from, say, the model of you're sitting there browsing the web with your PC and you're going to lots of different sites and you're having to log into each site. The site doesn't know you until you log in. It has to maintain its own database of who you are and what capabilities you have. In this case, it's a very lightweight thing where it's just the client sends out the ticket and boom, you have those capabilities and it knows who you are. This only works with the services that come with Microsoft TV Server. It's not a general purpose mechanism that you could put in Joe Random, service site, integrate into your Apache HTTP. If you wanted something like that, you should look at using the Microsoft Passport, which is somewhat similar, but a much more general purpose mechanism. And not as tightly integrated, doesn't give you some of the availability and scalability stuff that we get through this mechanism. Anything else on login model?
Is there going to be some, you talked about a house account. One of the things that's interactive to the extent that I've noticed is if you go through this login, if you're not connected at the time you hit a link, you trip over that. And I'm just wondering.
So the question is what would happen with this in terms of and I alluded to this a little bit, if you have a household account, when are you forced to become a user and when are you not? And that's something that I think is more of a user interface question than this. We could do it at sort of any level. We decide we wanted to let household account browse the web, in which case, sure, you go to all these sites and it would work just fine. The question is, though, if you find a site that you want to save as one of your favorites, should it be saved in the household favorites or a specific user favorites? If you go to a site that then does a mail to URL, well, obviously, if you're going to send mail, you need to be become a user. My initial thought is that when you started browsing the web, in addition, because depending on whether you have kid-safe, things associated with the account, you may not want some kid who's watching television to just hit a link and suddenly be on the web, because you may want to restrict them to the kid-safe account. The first pass I'd do for our first customer ship would be to browse the web. You'd have to go out of the household account and into the specific account. But notice, if you only have one user on the box and they don't have a password, it's completely transparent. They wouldn't even notice that it happened. It's only when you have multiple users, and we could even look only if you had multiple users and some of them had restricted capabilities. I mean, that's where it gets hard, is you have to look at, what you're really intending on doing. We could support any and all of that. It really becomes a question of what the user experience that they want to give their customers. So from TV server, it's not a problem. It is a problem, and I don't think anyone has really thought through the full implications of this and what they entail and what they mean. Okay, so moving on from here, the two-way authentication. One of the things that we do, and this is fairly low-level detail, but I think it gives you some idea of, if people hear, oh, I hear that you guys encrypt stuff, why are you doing that? Why not just use BPI, which is built into DOCSIS? Well, BPI, first of all, only encrypts from the cable modem to the CMTS. If you're going any sort of long-haul network or any sort of IP traffic, it's not encrypted over that section of the communication link. In addition, BPI is an optional part of the DOCSIS standard. I believe that the cable modems that are going into the DC5000s will all have it, but some customers may have cable modems that don't actually have BPI. So we have a end-to-end encrypted channel that will go ahead and give you that security regardless of whether you have BPI, didn't have BPI, whether you were going over some part of the IP network where you wanted stuff encrypted or not. We do the end-to-end encryption. That gives you the privacy. But perhaps what's even more important is it provides a very light way of getting two-way authentication. This two-way authentication means that the server knows that it's an authorized client that's talking to it, and the client knows that it's talking to part of the MSTV service and therefore can trust it to do things that it wouldn't trust any random website. So a good example of that is that because the client trusts the service, it can allow the service to modify its NVRAM, update EPG listings, reboot itself, remove pages from the client cache, and this can give us much better user experience. For instance, when you're viewing mail, normally you have to hit refresh to see if any new mail has showed up in your inbox when you're sitting on that page. We can go ahead and automatically remove that page from the cache, forcing a refresh when the new mail message arrives. So there's a lot of stuff that we can do because we have this two-way trust between the client server that's provided by this light two-way authentication. And I'll talk a little bit more in the details of how we do it if anyone's interested, but the nice thing is, SSL, first of all, is not two-way authentication. It's only one way, and it's a quite expensive protocol. It involves multiple round trips on the way up, and it's a fairly expensive encrypted connection. This, because it's based on keys that are already present on the client and server, is a very lightweight encryption that involves no extra round trips. You just start encrypting it and sending out the data. And in addition, this means the service can trust that's a client where they paid their bills and everything's okay, because they wouldn't have received a ticket from Headwaiter if they weren't an authorized client. So it's a nice way of knowing that each service connect to, be it mail, favorites, whatever, doesn't have to requery the billing system and database to see, is this user still okay? Based on the presence of that ticket and that ticket provided over the encrypted connection, it knows that everything is working. A little more detail than you may want to know, but it's a useful feature, and people start asking about security and encryption and all that, it's useful background information. The other thing I alluded to is some of the client-server split. And that is that because we have in both the client and the server, we can move functionality around from where it may take place on a traditional PC ISP system. So for instance, we can go ahead and store the cookies and favorites on service instead of on the client. Some of the advantages of that is allow cheaper clients. You don't have to have local storage, better availability. That client dies, you can throw it in the trash, get another client, bring it out to your home, and it still works. All of your cookies, all of your favorites, anything else you've set up is still there. It also can allow shared access if you have multiple boxes in the home. If you have your favorites list, that favorites favorites list can be available on any of your boxes. For those of you with the PCs, you have your favorites list at office and your favorites list at home. And it's always that the machine you're on doesn't happen to have the favorite that you stored because it was on the other machine. This way it's stored on the server. It's provided, no matter where they're coming into the service from. We can do, again, some optimized, we can do some optimizations because we know what client is. This is some of the proxy content formatting work, and it allows you to centralize some of the expensive shared resources with the backups, upgrades, things like that. So it really is, by having both the client and the server, we think can provide a better end-to-end experience as a whole package. Questions? Yeah. There's not a benefit to the subscriber in their home. It's completely transparent to them. The main benefit to the MSO, the customer that we're selling it to, is that it allows a lot of the capabilities that come with our system. Without doing that, if we did some of this, we, for instance, couldn't enable those client functionalities without worrying, how do you trust whether the site you're talking with should be able to modify your NVRAM? So you could, without those, you would have a lot fewer things that you could do with a client, so the overall experience the user saw would not be the same. So for instance, you can connect one of our clients in OpenISP mode, just random ISPs, but when you do that, these client functions aren't available because no way we can know whether we trust those or don't trust them. So it's sort of an underlying, some underlying technology that enables a bunch of nice things on top of it. It's not really something I see as a direct selling point, but it's more if people start asking about the security of connection and what you do with it, I think that's something you could bring up and explain. I would, as a selling point, I'd look much more at it enables on top of it, that we do have this trust relationship between the client and the server, can therefore do all of these additional things. It provides this at a much lower cost in terms of number of round trips and amount of bandwidth that's taken up. But again, it's not really a visible feature, except as you try and scale up to 1 million users, it means you're making better use of network. Is that sort of, it's sort of a feature, and I wasn't sure I really want to go into it, but I decided it is important because people hear about it to understand what's down there. Okay? Okay.